All right, in this video, we're going to be looking at notes for lesson 2-1. We're going to be talking about types of numbers you'll find on the number line. We're also going to talk about the distance postulate and ruler postulate about distances between 2 points on a number line. So let's go. First of all, sets of numbers. We have what we call the real number set. The real number set is made up of all of these numbers in these sets. What sets am I talking about? Starting with way back when we learned the counting numbers, 1, 2, 3, right? Then you learned 0, that gave you the whole number. So now you have a bigger set, right? The whole numbers, 0, 1, 2, and 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Then you include the integers, all their opposites, and all the whole numbers. And then you have the rational numbers, which includes the decimals and fractions. Now, as long as the decimals have to either terminate or repeat. They're all part of the rationals, which of course part of the rationals includes the integers, whole numbers, and counting numbers. Then you go to the irrational numbers, which are all those decimals that never end, never repeat, like pi or the square root of 3. And when you combine the irrational and the rational numbers together, you end up with this set of real numbers. So everything together, all this together, makes up the real numbers. All these other sets together are the real numbers. Now you find these real numbers on a number line. Any number line, you can label where a real number is placed. I mean, look at this example right here. You have negative 8/10 repeating, but negative 1 is less than that, negative 1/2 is less than that, negative 2 is less than that. In between them, and this should be right here. This is a typo by the maker of the worksheet. That should be a negative 1.8603, because this whole side over here, these are all the negatives. Boom. Then you have the positive side, and it goes to the right. And every real number has a place on the number line. All right, so let me scroll up here on our notes. Look at this next section. It says a number that corresponds to a point on the number line is called the coordinate of the point. Now, a lot of times we call coordinates, we think of the XY coordinate plane, but even a number line is a place to graph, and it just has one coordinate. One number goes with a point on the coordinate plane. It'll be a real number. So it's called a coordinate. So let's just underline that coordinate. And on the number line below, 10 is the coordinate of point A. The coordinate of point B is -4. Point C has coordinate 0 and is called the origin. So you have point C, coordinate 0, called the origin, which is right there. Pretty obvious. And then we move on to the next sentence. It says the distance between 2 points A and B on a number line can be found by using the distance and ruler postulates. What are those? Let's take a look. Let's slide up. The distance postulate says this in this box right here. For any 2 points, on a number line, and a given unit of measure, there is a unique positive real number called the measure of the distance between the points. That's a fancy way of saying when you have a distance, it's like you're measuring from one point to the other. That's where rulers come into play, tape measures, measuring devices. That's pretty obvious. And then you have the ruler postulate, which is the one right below it. And that says, this postulate, the points on a line can be paired with real numbers so that the measure of the distance between corresponding points is the positive difference of the numbers. Difference meaning subtract. So in order to, what this is saying is, In order to find the distance from point A to point B, the distance from A to B, the distance of A, B, you actually subtract the measurements. And you want to subtract the greater value minus the lesser value. That's the best way. That's why it says A minus B here. Now, if you do subtract B minus A, you've got to use the absolute value. And that is what we have down below in our notes. It talks about the distance here between, let's say, R and S. So you have 11 and a 3, 11 and a 3. If you subtract 11 minus 3, you get 8. Absolute value of that is 8. If you would take 3 minus 11, you get negative 8. But again, distance is an absolute value. It's a positive. So again, no matter which way you subtract, you should end up with a positive result because distances are measurements, and measurements are always going to be positive. All right, so in this number line right here, it's the same one we saw on the very first page, the very first side of these notes. You have these all these real numbers labeled at different spots on the number line. When we measure the distance on a number line, our answer will always be positive. Yep, always going to be positive. Let's go ahead and let's just look at a number line here. It says use the number line below to find each measure. Let's start with number 1. We need to find the distance from A to D. That's what that represents. AD is the distance from A to point D. Now, before you do any of these kind of problems, and look at any of these here, any of these distances, you're going to use this number line. And notice some of these points don't have any values with them. So we've got to calculate those values. So we've got to use our thinking skills. We do know that this is a -1 and this is a -3. And that distance from here to here, -1 minus -3 is a positive 2. That's 2. And there are 1, 2, 3, 4 equal parts. Well, if I cut that in half, each of those would represent 1. So 1 whole from -1 to here is 1 whole. And then from here to here is another whole. So on this number line, what I can do is I can label this -2 because I recognize from here to here is 1 whole, from here to here is 1 whole. I go the other way. So that's another 1 whole. So that would be a 0. And then another 1. There's 1. And then there's 2. And then there's 3. So it looks like each little distance between marks is a half. All right, so what I went ahead and did was, after I stopped the video, I just put in, I marked that E is actually going to be 2.5. Oh, that's a mistake. So be careful. It's not 2.5. That's going to be 1 1/2. It's between the 1 and the 2. 2.5 would be out here. I don't want that right now because E is 1 1/2. Now D, back to my highlighter, D, I think I had that right, is -0.5. It's between 0 and 1. Click over here. And then between -1 and -2 is -1 1/2. That would be C. And so on. So to find the distance between 2 points, you got to know what numbers they belong or what values they are first. So let's finish up with number 1. It says the distance between A and D. A is -3, D is -0.5. -0.5 is greater, so my subtraction is -1/2 minus -3. Now you know and I know that to subtract a negative is the same as adding its opposite, so it's the same as +3. So we're really going to add -1/2 plus 3, which ends up being a +2 1/2.